Hello, Algebra 2 students. Welcome to Unit 9, Day 2. What I would like you to do is please take a minute and try this warm-up page on your own. The warm-up page consists of questions 1 through 6 on page 1 of your notes for Unit 9, Day 2. So please take a minute, try these before you watch the explanation. You can either hit pause and stop the video, or try them and then come back to the video once you have tried questions 1 through 6. Once you've tried 1 through 6, come on back and I will explain the answers and see how you do. All right, so let's take a minute and go over the answers and see how you did here. Okay, number 1, this first one should be a geometric series. The ratio is 4, which means it does not have a common difference. And if you take a look, if you notice, if you want to check, what you're basically doing is 7 times 4 gives you 28, 28 times 4 gives you 112. 112 times 4 gives you 448. So the other thing you can do, remember, is you can also work backwards. So do 448 divided by 112, 112 divided by 28, and 28 divided by 7 to see if that gives you all the same answer. And when it does, that's going to tell you your common ratio, which in this case is 4. All right, so just as a quick refresher, your explicit formula for a geometric series is going to be a sub n equals a sub 1, remember that's your first term, times your common ratio to the n minus 1. So in this case, I'm going to say a sub n equals, my first term was 7, my common ratio, which I just decided was 4, all to the n minus 1. Now remember, series notation, so this is just finding a specific one term in that sequence. Series notation is basically taking that your sequence and just putting a plus sign between it. Okay, so it's just telling us let's add everything up. And as a quick refresher, your series notation, remember that's when we're going to use this big E or sigma, and that tells me to add everything up. So n equals 1, that means start with the first number, which in this case is 7. Add up to infinity. So I'm going to add every single number possible, and then I'm just going to put my formula in there. 7 times 4 to the n minus 1. All right, now let's find the sum of the series from n equals 1 to 12. Now you could sit there and you could actually do this by hand, or you could use your graphing calculator. Sometimes I kind of make a table for this. So if we have n and a sub n, if this is helpful to you. So n1, that just tells you that's the first number in the series, that's 7. 2, that's the second number in the series, that's 28. 3, that tells you that's in the third position, and that is going to be 112. So you could keep going all the way up to 12 and then add your numbers, or remember you can use your graphing calculator. And let me just show you quickly how to do that on your graphing calculator if you need a refresher. Okay, so you're going to go to Stat, you're going to go to Edit, make sure to clear your list, highlight L1, hit Clear, hit enter, and what you're going to do is you're going to type in sort of like your X values here, or what numbers in the position that you're summing. So here we're just going to type in 1 through 12. 1, 2, 3, 4. Okay, so that's like the top number of your table. So think of those are kind of like your input values or your X values. So list 2, think of this as now your n. So what is our formula here? Our formula here is take a sub 1, okay, which in this case is going to be 7. So I'm going to type in 7 times, make sure you put this in parentheses, 4. I'm just typing in my formula, all raised to the n minus 1. Now n, remember that's going to be you plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're gathering those numbers from list 1. So we're going to go second L1, okay, minus 1, and then hit enter, and notice that's going to give you all of sort of like your Y values, 7, 28, 112. Okay, so now remember to get your sum, make sure you quit. Okay, you're going to go to second Stat, because we're doing, notice how it says lists, we're doing something with lists. We want to do a math with the list, and we want to sum the list. You're going to go down to number 5, hit enter, and you're going to hit second L2 because we're summing list 2, not list 1. Okay, and that gives us a pretty large number of 3,914,6,835. So 3,000,000, I wrote that wrong, sorry. 39,146,835. Okay. All right. If you have any questions on that, please let me know. All right. So let's take a look at question number 2. So this one right here, this one is going to be arithmetic. Okay. And why? Because if you look, every single time I'm adding 3, okay, to get to my next number, so I don't have a common ratio, I have a common difference of positive 3. It's positive because I'm adding. Remember your explicit formula here, that is going to be a sub n, which that tells you that's any term in the sequence equals your first term plus your common difference times n minus 1. So let's just fill in what we have. A sub n stays there. My first term was 4. My common difference was 3 to the n minus 1. And if you want to simplify that, you can. So you're just distributing your 3 to both of these. And 4 minus 3 is 1. So you could write this as 1 plus 3n. And if you notice, this is actually the same thing as an equation of a line with your y-intercept and your slope. Okay. All right, so series notation, remember that's just putting your sigma here to tell, let's add up all the y values. Okay, we're starting with n equals 1 because that means we're starting, this is your first position, second position, third position, fourth, fifth, and sixth, all the way up to infinity. Okay, and then you're just going to put your formula right there. I just made it a little bit easier by doing 1 plus 3n or 3n plus 1. All right, doesn't matter how you do that. And then on your graphing calculator, you're going to do the same thing here. So on your graphing calculator, we already have 1 through 12 in my graphing calculator. So now when I go to edit, okay, I'm just going to change list 2 because I already have 1 through 12 in list 1. So what I'm going to do is I am going to plug in my formula. It doesn't matter which one you do. So you're going to do 1 plus 3. Now remember, I'm getting my n values from list 1. So I'm going to hit second list 1, hit enter. It's going to fill that in. So you're going to go to make sure you quit the list, okay, or it's not going to give you the correct sum. Second list, over to math, down to number 5, and we're summing list 2. Okay, and that's going to give us 246, a little bit smaller of a number than we had last time. Okay, so then let's take a look at this last portion here. It says, find the first 5 terms of the sequence defined by a sub 4 equals 6, and the difference is negative 3. Now you have 2 choices. The way you could do this, you could think of making a table, n and a sub n. So n is your position. So position 1, position 2, position 3, position 4, position 5. Or what you could do and then plug in, so this 4 tells us the number in the 4th position is 6. We know the common difference is negative 3. So every single time to get to my next number, I'm subtracting 3. Okay, so 6 minus 3 is going to give me 3 here. Or what I could do is now to work backwards, I have to add 3 because I'm working backwards. So I'm going to do 3. I lied. I didn't work backwards. Okay, I'm going to do 9. Okay, and then I'm going to add 3 to get 12 and 15. Okay, that's the first way that you could do it. The second way that you could do it is you could actually write and find your formula, okay, and then get your first term from your formula. The second way you could do this is actually find your first term, and this is your general formula. A sub n equals your first term plus your common difference times n minus 1. So what we're going to do is you can just fill in the numbers you have. So a sub n, that tells you the actual number, so that's going to be your 6. Okay, your a sub 1, our first term, we don't actually know, so we're going to leave that. We know our common difference is negative 3. And then n is actually, that's your 4 because that tells you the position of your number. So then you can just go through and solve this. So when you solve this, you get a sub 1 is equal to 15. So that tells you the number in your first position is 15. And then you can just work from there. You can actually subtract 3 and do the same thing. You get your 12, your 9, your 6, and your 3.